We're moving on to the next part of the Rust programming language. In the last video, we created a guessing game, and now we're going to be going to the next section, which is common programming concepts. So over here, it basically starts with some extra things like, let's suppose this chapter covers concepts that appear in almost every programming language and how they work in Rust. Many programming languages have much in common at their core. That is really true. None of the concepts presented in this chapter are unique to Rust, but we'll discuss them in the context of Rust and explain the conventions around using these concepts. Each programming language has its own conventions of writing, so Rust has its own. So specifically, you learn about variables, basic types, functions, comments, and control flow. These foundations will be in every Rust program, and learning them early will give you a strong core to start from. So right now there's going to be keywords. Keywords are basically reserved words, and basically it feels like we're going to the introduction level of programming again. So this is pretty simple, and what we're going to do is, you can see that over here they're saying variables and mutability. Mutability means changeability. Okay, so in your new variables directory, so basically it's saying create a directory called cargo new. First it's saying create a project, generate a new project called variables in your projects directory by using project new cargo new variables. So let's do this quickly. So I'm going to show you, this is my directory, this is my command prompt. It's opened up in projects, so you can see Rust, and Rust is a folder. And what we're going to do is we're essentially going to put this on the left and this on the right, actually this one. So yeah, so this and this thing. So what we're gonna do here is we're gonna first create a directory here. So I'm just gonna say, yeah, so I'm gonna say cargo, and then we have new, and then we have variables as our project name. Okay, now this is created binary application variables. And then in your new variables directory, open source main.rs and replace its code with the following code, which won't compile just yet. So essentially they're saying replace it with this piece of code. So let's go to the main.rs. So right now you have to cd inside variables folder. It's basically going to be a folder. Now you could open it up using code and dot. And this is going to open it up. So you see over here source and main.rs. This is just the hello world function. What we could do is we could just put it on the right, and it's saying essentially you could replace the main.rs with this function instead. So we just copy it and paste it right here. Okay, so now you could see let x is equal to, and essentially I'm getting these kind of values here. This is basically from my extension that I installed. It's for Rust, so it's for Rust basically, and I downloaded it specifically. I just typed in Rust and it gave me this extension, Rust Analyzer. All right, so we could go back here and say let x is equal to 5, and then we have print ln, and then the value of x is this. We're trying to change x to 6. It's not going to work. It's going to give an error. Save and run the program using cargo run, and you should receive an error because regarding an immutability error as shown in the output. So and even if we try to run this thing, it's going to give us an error. So we'll go here and we'll say cargo run, and you'll see that there's compiling variables, and then you can see cannot assign twice to immutable variable x. So essentially we gotta have to change this. It's immutable and we have to change it. So when you by default it's immutable, but if you put the keyword mut inside, that thing will be gone, and now it's going to work. So it could be 5 in the beginning, and then it could change to 6 since it's being assigned over here, right? Reassigned. So now if you run it, and you could say cargo run, now you can see first the value of x was 5, and then the value of x is 6. This is important. Now it's just going to say the same stuff. It's going to say just put the MUT. Adding MUT also conveys intent to future readers of the code by indicating that other parts of the code will be changing this variable's value, right? So other parts of this code will be changing this variable's value, and this is really nice, and it runs. Constants, on the other hand, are just by default. So Like immutable variables, constants are values that are bound to a name and are not allowed to change, but there are a few differences between constants and variables. First, you aren't allowed to use mut with constants. And constants aren't just immutable by default, they're always immutable. You declare the constants using the const keyword instead of the let keyword, and the type of the value must be annotated. So we'll cover types and type annotations in the next section. Data types don't worry about the details right now. Just know that you must always annotate the type. Okay, so over here you can see here's an example of a constant declaration. So we have const 3 hours in seconds, and it's converting 3 hours. So 60, 60, and then 3. Converts it and puts in a variable name. So, basically the constant's name is 3 hours in seconds, and its value is set to the result of multiplying 60, the number of seconds in a minute, by 60, the number of minutes in an hour, by 3, the number of hours we want to count in this program. Essentially, that's the logic. Rust naming conventions for constants is use all uppercase and underscores between the words. So this is basically the way to do this. It's pretty simple here. Now, after that, we have shadowing, another concept here. As you saw in the guessing game tutorial in chapter 2, we can declare a new variable with the same name as a previous variable. Rustatians say that the first variable is shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable. In effect, the second variable overshadows the first, taking any uses of the variable name to itself until either it itself is overshadowed or basically shadowed, or the scope ends. We can shadow a variable by using the same variable's name and repeating the use of the let keyword as follows. So we can see over here let x is equal to 5, and after that we basically shadow the variable by saying x plus 1, essentially a 5 and then 6, and then put in x. And then you can see over here there's this, and then the inner scope, and then there's this outer scope. The program first binds x to the value of 5, then it creates a new variable x by repeating let x is equal to, taking the original value and adding 1, so that the value of x is then 6, obviously. Then within an inner scope, so this is the inner scope, created using the curly brackets, the third let variable statement also shadows x and creates a new variable multiplying the previous value by 2. So basically it's x 6 and then 6 multiplied by 2, which is 12, and this is a new variable, and now it's going to have 12, and give it x to a value of 12. When the scope is over, the inner shadowing ends and x returns to being 6. So basically this is just limited to this scope, and when you come out of this scope, it's still back to this original shadowed value, which is 6. So it's essentially not going to be 12, but it's going to go back to 6, and then the value of the x will be 6. So when the scope is over, the inner shadowing ends and x returns to being 6. When we run this program, it will output the following. So the value of the inner scope, the value of x is 6. So essentially, this is shadowing is different from from making a variable as mut, because we'll get a compile time error if we accidentally try to reassign to this variable without using the let keyword. By using let, we can perform few transformations on a value, but have the variable be immutable after those transformations have been completed. So that's why we basically use the let keyword for all of these reassignments, right? And that's why it's working. Otherwise, it wouldn't work, and it would be immutable, and you would have to use the mut keyword. But this is a shadowing concept. It's completely different. And you'll see let spaces equal to this, and let spaces spaces.len. The first spaces variable is a string name, and the second spaces variable is a number type. Okay? It tells you the length of the space. So essentially, I could see like 1, 2, and 3. So instead, you can reuse the simpler spaces name. However, if we try to use mut for this, we're shown we'll get a compile time error, because we say immutable and we say. Okay, so essentially there are two different types of variables here. The first spaces variable is a string name, and the second spaces variable is a number type. The shadowing thus spares us from having to come up with different names such as spacer and numster, basically spaces num. That normally happens in different programming, and instead we can reuse the simpler spaces name However, if we try to use mut for this, as shown here, we'll get a compile time error because basically we're trying to redefine that. The error says that we're not allowed to mutate a variable's type. This is completely different. It's creating different variables. Every time you use the let keyword, it creates a new variable. And then you could also use the same name. So this mut means when you're trying to use the same variable and trying to change its data type, but it won't be allowed because that's actually an error, right? So now we've explored how variables work. Let's look at more data types they can have. So let's go and check the data types in Rust. So I'll go back here on the top and let's just open up. Okay, sorry. Variables and mutability, and there you go, data types. So every value in Rust is of a certain data type, which tells Rust what kind of data is being specified. So it knows how to work with the data. We'll look at the two type subsets, scalar and compound. So we have scalar, and then we have compound. So scalar types and integer types, and then we have integer overflow, floating point types, numeric numbers, Boolean types, true or false values, the character type, which is single character, and then the compound types, which are the tuple type. A tuple is a general way of grouping together a number of values with a variety of types into one compound type. Tuples have a fixed length. Once declared, they cannot grow or shrink in size because they are immutable. So fixed length. And then we have this. And then we have essentially more tests related to this, and the array type. You could create an array in Rust. This is an array of months, and then these are the array with a size of 5, and then it has the values inside of it. So normally this is all there. We have this thing as well, which is invalid array element access. Generally trying to access the element that is invalid. So you can't try, access the value of an element that index. The code compiles successfully. If you run this code, cargo run, program will print out the corresponding value at the index and the variable. But if you instead enter a number past the end of the array, such as 10, you'll see the output like this. So essentially, it gives us the error as well. So we could conclude a little bit. We have an understanding of the data types that are available in Rust programming language, and we normally see like this is a constant pattern in every single programming language. You normally start with all these kind of hello world and then create a small project like a game, and then you basically look at the variables and data types and functions and comments and control flow, conditionals, for loops, iterations, and there's some called ownership, the concept of ownership, and defining an instance, and enums, and pattern matching. So all of this stuff is in Rust. So it's not really that big of a deal. You could actually easily understand this language with a few days if you're pretty experienced with other programming languages. So yeah, keep watching the channel. Thank you so much.